Welcome to Organic Chemistry, Lesson 3. So far, we have looked at the introduction to organic chemistry. In the previous video, we looked at alkenes, and in this video, we're going to take a look at alkenes. Then, in the next 3 videos, we'll take a look at alcohols, carboxylic acids and esters, and then polymers. So, we discussed the family alkenes. So now we go to the next family, alkenes. So here are some general properties or general information about alkenes. First, they are called unsaturated hydrocarbons. So when it comes to hydrocarbons, there are basically 3 types of hydrocarbons: alkanes, alkenes, and alkynes. In our syllabus, we are just going to concentrate on alkanes and alkenes mostly. So alkenes and alkynes are called unsaturated hydrocarbons, while alkanes are called saturated. Why are they called unsaturated? So there must be a reason why they are called unsaturated. The general formula for alkenes is CnH2n, where n can be an integer. So if C is 4 here, it means H is going to be 2 times 4, 8. So whenever you see a hydrocarbon that has the number of carbon atoms being doubled by the number of hydrogen atoms, or maybe the number of hydrogen atoms being twice the number of carbon atoms, then know that it is an alkene. The functional group is a double carbon-to-carbon covalent bond. So alkenes have at least one double carbon-to-carbon covalent bond. They all end with ene as the suffix. So now, why are they called unsaturated hydrocarbon? It's because they have a double bond between carbon atoms. So how is having a double bond connected to being unsaturated? So the double bond implies that there are not enough hydrogen atoms for the carbon atom to bond to. So it bonds with another carbon atom twice, or with double bonds. They share 2 pairs of electrons. Okay, so in case there was a hydrogen atom, then this double bond can break into a single bond, so that the other bond is formed between the carbon and the hydrogen atom or atoms. So in short, they are called unsaturated because they don't have a maximum number. They don't have a maximum number of hydrogen carbon atoms. Of the hydrogen atoms to bond to, unlike the saturated one, the alkenes. So when you compare an alkane with its corresponding alkene, for example, if you get methane and methane, or propane and propene, you're going to see that they have 2 hydrogen atoms less than their corresponding alkanes. So propane is going to have 2 more hydrogen atoms as compared to propene. So of course, again, not having enough space here, but anyway, these are just some examples of alkenes, their molecular formula, their structure formula, and the condensed formula. So ethene is written as C2H4, and as you can see, we have 2 carbon atoms, a double bond, then we populate them with hydrogen atoms. Remember, the maximum number of bonds a carbon atom can form is 4. So we have 1, 2, 3, 4. Even this one we have 1, 2, 3, 4. Then propene, C3H6, it is this one with a single double bond here, and the condensed formula of course is CH2 bonded to CH bonded to CH3. So again, due to space, I can't show everything here. Then we have butene, which is C4H8 with a single carbon-to-carbon double bond. We also have pentene, C5H10, again with a single carbon-to-carbon double bond. Next, look at the preparation. So when we take a look at preparation, just like in our alkenes, we just looked at how methane is prepared. The idea is they have similar methods of preparing. So even for alkenes, we're going to use ethene as an example. So the first method that is used is catalytic cracking of alkenes. We talked about cracking when we were studying alkenes, and in that cracking that I showed as an example, it was revealed that an alkene was formed. So that is actually the method that is used to prepare alkenes. An alkene is cracked to produce alkenes and other substances. Remember, cracking is just breaking a complex molecule into simpler molecule. So the reaction is simple. We have this alkane, which has 17 carbon atoms. We haven't learned how to name this. It's out of our syllabus. So this one is cracked to produce this compound here, and this alkene here, and this alkane here. So that's how alkenes are prepared. So the apparatus is you get a ceramic hull which is soaked in paraffin. So of course paraffin has the alkane that has to be broken. So you make sure that you insert a broken pot here. So this broken pot is going to act as a catalyst for this reaction. So once you do this, the paraffin is going to be cracked to form ethene and the other two substances. So the conditions are the temperature should be 600 degrees Celsius. The catalyst, you can use aluminium oxide, Al2O3. Also, the broken pot can act as a catalyst. Next, we're going to take a look at the second method used to prepare alkenes. So this one is called dehydration of ethanol. So ethanol is an organic compound that we're going to take a look at next when we will be studying alcohols. Even though we haven't looked at it anyway, we're going to use it because it is used in the preparation of ethane. So we're going to study it. So dehydration of ethanol. Dehydrate is just to remove water. When someone says they are dehydrated, it means they have lost water. So ethanol is dehydrated. Water is removed from ethanol. Then you have an alkene. So ethene can be prepared by the dehydration of ethanol using concentrated sulfuric acid as a drying agent. Remember, concentrated sulfuric acid is mainly used as a drying agent. So this sulfuric acid is a drying agent, so it will dry up the ethanol by absorbing all the water that is in the ethanol. So this is the reaction where we have ethanol here. Once you put it in, it is in contact with sulfuric acid, the water is going to be removed. So we're going to remain with ethene and water. So not remaining, we're going to have ethene and water. Ethene is what we collect as a gas. Then water, of course, can be discarded. So the reaction is represented using structural formula as this. We have alcohol here, which is ethanol. So this ethanol, when it loses water, it's going to lose one hydrogen, one oxygen, and one hydrogen. So once that happens, this carbon is going to it will lose this oxygen, this hydrogen, and this hydrogen, so that we remain with these two hydrogens here and these two hydrogens here. Then the two carbon atoms, since this one will have one bond lost and this one will have one bond lost, they are going to form a bond here, so that they have 4 bonds and 4 bonds here. The objective is to make sure that a carbon has 4 bonds. So when this is lost and this is lost, it means 2 bonds have been broken. So this carbon needs 1 bond and this carbon needs 1 bond. So they'll react with each other. They'll form a bond with each other. So they each have 4 bonds, 1, 2, 3, 4, and this one 1, 2, 3, 4, and what has been produced. So what are the conditions that makes this reaction possible? The temperature should be 180 degrees Celsius. The dehydrating agent or the drying agent should be concentrated sulfuric acid. Other than the preparation, we're going to discuss something interesting, which is test for unsaturation or test for alkenes. If you have been given a hydrocarbon, how can you tell that that hydrocarbon is an alkene or it's an alkane? So we do some tests which are called tests for unsaturation, or which is also called test for alkenes. So in test one, you shake an alkene with bromine water. Bromine water is water that has bromine. So when you do this, then this is going to happen. The brown color of bromine disappears immediately. If this happens, it means whatever you are shaking the alkene with bromine water, whatever you were shaking the hydrocarbon, because when you're doing the test, you don't know if it's an alkene. You want to test. So in short, you have to shake the hydrocarbon with bromine water. If the bromine water disappears, the brown color of the bromine water disappears. If the mixture of bromine and water becomes colorless, then it means that hydrocarbon is an alkene. So let me just say that again. You get the hydrocarbon, you shake it with bromine water. The bromine water is brown. So when it changes color from brown to colorless, then it means that hydrocarbon is an alkene. If it does not change any color, then it means that hydrocarbon is an alkane, the saturated one. So in short, alkenes decolorize as bromine water, while alkenes do not. But why? So when ethene reacts with bromine water, it forms a colorless compound called 1,2-dibromoethane. 1,2-dibromoethane. So after doing the nomenclature, how to name hydrocarbons using the international standard, International Union of Pure and Applied Chemistry, you should be able to draw this structure just from the name. 1,2-dibromoethane. I keep on failing to pronounce it. 1,2-dibromoethane. So how do you draw this structure? Remember, this part ethane shows you the longest chain. So it says that the longest chain is made of something that is an ethane. An ethane has what? It has 2 carbon atoms. So the longest chain is made of 2 carbon atoms. Then this bromo, it is a functional group, some sort of a functional group. So these bromo are just some functional groups that are attached to the 2 carbon atoms. And the bromo, there are 2. That's why it's dibromo. So there are 2 bromo. So this bromo is actually bromine that is attached to this ethane at 2 carbon atoms. But where exactly? So these numbers will tell you where. The first bromine is on carbon atom 1. The second bromine is on carbon number 2. So the structure will have a bromine at carbon 1 and bromine at carbon 2. And it's going to be made of 2 carbon atoms that are connected to each other. So the reaction is this: ethene reacting with bromine to form 1,2-dibromoethane. The structure is this, so of ethene, bromine, and bromine. So what happens is these hydrogens are going to give space to bromine, then the bonds here are going to break, and then there will be new bonds that are going to be formed. So as you can see, it is more like ethane, but instead of hydrogen atoms here, it has bromine atoms. The second test is you add acidified potassium permanganate 7 solution to the hydrocarbon. So when you do that, when you add acidified potassium permanganate, something is going to happen. So if the purple color of potassium permanganate turns colorless, then an alkene is present. But if it does not turn colorless, then there is no alkene, there is an alkane. So now let's take a look at chemical properties of alkenes as we finish this topic, or should I say this subtopic. So alkenes are more reactive than alkanes. Why? Because of the double bond. That double bond makes alkenes more reactive. Alkenes are balanced, they have everything that they want. Well, alkenes, they need more atoms to bond with because of the double bond carbon, so that double bond can break to form new bonds. That's why alkenes are more reactive than alkanes. So this is what I've just explained as a summary. So the first reaction, actually there are two reactions which alkenes participate in. The first is combustion, just like alkanes. So in alkanes we learned about the two types of combustion depending on the amount of oxygen that is there. Even here it's the same, so we're not going to go into a limited supply and full supply like in complete combustion and complete combustion. No, we're just going to give a brief summary of what happens in combustion of alkenes. So alkenes reacts with oxygen to form carbon dioxide and water. So here is an example where we have ethene reacting with oxygen to form carbon dioxide and water. Nothing complicated here, something that we already know. So the second type of reaction is addition reaction. So on addition reaction, we have about three types of reaction, or three examples of addition reactions where alkenes are involved. The question is, what is addition reaction? So addition reaction is simply a reaction where a molecule is added to an unsaturated molecule by breaking a double bond, which is actually what we're talking about. What makes alkenes reactive? The double bond. So addition reaction is where you add something, you add the molecule to another molecule by breaking a double bond. And that molecule should, of course, be unsaturated. Just the word unsaturated means it needs more. So examples of addition reaction involving supposed to be ethene here, not ethane. The first is halogenation. Remember, halogenation, just like in alkanes, is a reaction which involves halogens. So ethene reacts with chlorine to form 1,2-dichloroethane. 1,2-dichloroethane. What is 1,2-dichloroethane? So again, I will waste some time here. So dichloroethane, it means it's an ethane made of two carbon atoms. Then we have two chlorine atoms, one at the first carbon atom, the other one at second carbon atom. So it's an ethane, but of course with two hydrogen atoms replaced by chlorine. So this is the reaction where ethene reacts with chlorine to form 1,2-dichloroethane. So using structural formula, we have ethene here. So this ethene reacts with chlorine. So the two chlorine atoms are going to take the place of, actually they're not going to take the place of anything. So the two chlorine atoms here are going to come here. This bond is going to be broken and the carbon are going to form other bonds. Okay, so this bond is going to be broken, then this carbon is going to form a bond and this carbon is going to form a bond. So we have chlorine and we have chlorine here. So this is 1,2 di, since there are two chlorines, chloro, and it is an ethane. The second addition reaction is hydrogenation. Hydrogenation is a reaction which basically involves hydrogen. It is an additional reaction that involves hydrogen. So alkenes reacts with hydrogen to form corresponding alkanes. So if you take methane, for example, you react it with hydrogen in addition, it will form methane. This should be something that should be kind of intuitive, in that alkenes are unsaturated because they are missing some hydrogen atoms. So if you give them those two hydrogen atoms, then they turn into alkenes. Okay, so this is hydrogenation. Hydrogenation, in short, makes the unsaturated compound to become saturated. Ethene reacts with hydrogen to form ethane, for example. So this is ethene. When you give it two hydrogen atoms, the hydrogen atoms will combine with these, and we're going to have 6 hydrogen atoms, which is ethane. So using structure formula, so we have ethene reacting with hydrogen. So the bond here is going to be broken and two new bonds are going to be formed to accommodate the two hydrogen atoms, and this is ethane. So it is now saturated. So conditions for this reaction are the temperature should be about 200 degrees Celsius, so it's supposed to be 200 here. The catalyst should be nickel metal. Then there's this important point about hydrogenation. The reaction is important in the industry because it is used in the production of margarine from unsaturated vegetable oils. So to form margarine, unsaturated vegetable oils are reacted with hydrogen, then they become saturated. So in short, oils are oily, like cooking oil. So when you saturate it, it will become like fats, like butter. So that's what they do. They just add hydrogen to the unsaturated oils, then they will turn into fats. So, in short, vegetables are changed into fats which are saturated by hydrogenation. The last one is hydration. Hydration is all about adding water. So, ethene reacts with steam in the presence of phosphoric acid to form ethanol. So, when you react ethene with water, then you're going to make ethanol. So, we have ethene reacting with water to form ethanol. If you recall this reaction, it is also used to prepare ethene, where ethanol has water removed. If you bring in a dry agent, concentrated sulfuric acid, then water is going to be removed and ethanol is going to turn into ethene and water, which is one method of preparing ethene. So the opposite is true, where again you add water to ethene and you form this alcohol ethanol. Interesting. So using structure formula, we've got ethene, then we bring in HOH. So the bond is going to break here. So one carbon will take the hydrogen, this hydrogen, the other carbon is going to take OH. So this. The conditions are temperature of 300 degrees Celsius. The catalyst, like I said, is phosphoric acid, H3PO4. And the pressure should be 65 atmospheres. Uses of ethene. So this is the last part of this subtopic, uses of ethene. It is used in the manufacture of plastics. It is also used in the manufacture of ethanol. And finally, it is used in the process of ripening fruits. So this marks the end of lesson 3. Our next lesson is going to be interesting because we're going to forget about hydrocarbons. We're going to talk about alcohols, so that those who dream to form brewing companies in future, they are going to at least have something to start from. This marks the end of this part of the topic. Happy solving.